Hi, I'm Nicholas Gustafsson. I'm a Principal Program Manager in Visual Studio at Microsoft. And I'm here today to talk about a incubation project that we call Casablanca. Incubation efforts are things where we're really looking for feedback rather than for people to use it for real production software. And Casablanca fits into exactly that mold. It is a developer division project released on Dev Labs. It is not part of Windows. Our intent for Casablanca is to turn it into an Azure SDK for C++. It is, as I said, an incubation effort, and what that means for you is that we may never ship it if the feedback is from the community and from our customers that this is not exactly what we needed. Then we may not ship it. It may also take some time before it's released as supported software. And it's definitely not something that should be used for production code. So with those caveats, I want to go into and show you what it is and why I think you should take an interest in it perhaps and give it a chance. Give it a try. C++ in the cloud is not necessarily something that leaps to the imagination, so to speak. We think, however, that C++ has some usage in the cloud that are very interesting in the future. People choose C++ because it's close to the hardware. That gives you control, it gives you raw performance, and sometimes just better latency and throughput in general. C++ also is chosen often because it is a cross-platform language. It's supported on pretty much every operating system, every environment, and it is, at its core, not tied to any particular underlying platform. And that allows customers, developers I should say, to maximize ROI on their investments in libraries and things like that. It is also compatible with a lot of existing software. C and C++ often form sort of the core of other languages, their virtual machines or their underlying library implementations. So it's kind of at the epicenter of a lot of technologies. C++ cloud scenarios, the reasons that we think that C++ is a very relevant language for the cloud involve the highly performance-intensive services. Things like signal processing dependent services, entertainment, movie rendering, game servers, things that need to massively scale in data processing, and typical old-fashioned high-performance computing type of scientific or mathematical workloads, weather simulation, and those types of things. We also think that C++ in the cloud is very important for the re-engineering for cloud scenarios where existing applications that work well in an on-premise environment or so need to be re-engineered to work well in the cloud. And the cloud environment is, in many ways, similar to an on-premise server environment, and in some ways it's also quite different. And that difference needs to be taken into account when you re-engineer for the cloud. And we think that there's a place for C++ to take part in the re-engineering efforts of existing applications for the cloud. What Casablanca enables here is, in the first iteration at least, or in the first go-around, accessing REST services using modern C++. And I'll describe shortly what I mean by modern C++. Writing Azure-based services as well as on-premise REST services in modern C++. Composing asynchronous libraries in C++. And we also enable what we consider a well-proven pattern called the actors pattern in C++. By modern C++, we mean something else than C with classes, something else than just using naked raw pointers everywhere, and null terminated strings and things like that. We think of modern C++ as a highly evolved language. C++11 is the embodiment of that. That means using standard template library classes for your collections. That means using shared pointers. It means using lambdas, etc. We think that REST is a very interesting aspect of distributed computing and the sort of the cloud interactions, because it's simple and it's ubiquitous. There's a lot of REST services providing a lot of value in the cloud and elsewhere right now. We've also put a lot of thought into asynchronous computing and how we can allow asynchronous libraries to be composed in C++, leveraging the modern C++ features such as lambdas and move constructors and such. Asynchronous is very hard and is very important. Asynchronous is important on clients because it unblocks graphical UI threads. It's important on the server because you spend a lot of time waiting for I/O, and using blocking or synchronous APIs consumes a lot of resources while you're waiting and effectively doing nothing. The architecture of Casablanca, which is really just a block diagram of the pieces that we put into this library, is like this. We have a bunch of pieces at the bottom that are yellow here, which is like the foundation. These are things in Windows and other libraries, like PPL is the parallel pattern library that we are shipping in Visual C++. I/O completion ports, things that are already there in the Microsoft platforms. On top of that, we're building a number of, most of them are fairly thin layers, mapping these underlying APIs that are perhaps C libraries or COM libraries and API using patterns like that to modern C++, using heavy use of templates and lambdas and things like that. In the DevLabs release that we put out earlier here, we have just a subset of this implemented, and we may not actually go and implement all the boxes that you see in this diagram. We have an HTTP client and a listener. We have some TCP, asynchronous TCP functionality. We have a JSON parser and writer. We have a binary serialization library. We have a library for Azure storage, and we have a library for C++ actors. We're also doing some asynchronous file I/O in one of our libraries. But there are also big boxes here that we will never build, but maybe others will. And there are also pieces that we may decide, based on customer feedback from you and others, that they're not that important. So this is a sort of an intentional diagram displaying what we could build. Some of it is already built, some of it is not. And around all of this, on top of all of this, is hosting environments. IIS, for example, is one of the environments that Casablanca fits into. We obviously sit in Azure. That's, largely the point of Casablanca is to be an Azure SDK. But you can also run it just on Windows 7 or Windows 2008 server, of course, 2008 R2. I thought it would make sense to spend most of the rest of the time here looking at code and showing you some of the samples that we shipped in Casablanca. These are things that you can go to MSDN DevLabs, download the installers, get the stuff onto your machine, and go through these things yourselves. But I thought it would be interesting to go through it and show you what it is that we mean by modern C++ and what Casablanca looks like. I'm going to try to go through 5 different things. First, I'm going to start with a trivial HTTP service. Then I'm going to move, and it really is trivial. It's like the hello world of HTTP services. I'm then going to move to a hosted HTTP service, one that is more realistic at least in its structure, maybe not in what it's doing. It's still kind of an hello world from that perspective, but it can serve as a template for building more interesting things. I'm going to show you a simple Windows 8 HTTP client built with Casablanca. It is Windows 8 because we think Windows 8 is a very exciting environment to show off client code in. But it is not the case that Casablanca is the preferred or a best way necessarily of doing Windows 8 as it comes out, given in particular that Casablanca is an incubation effort. But it's worth looking at it from just a client perspective. I'm going to show you a more realistic HTTP service that is the back end of a multiplayer blackjack game. And then I'm going to show you the game client. And again, in the client, the objective is to show you what a Casablanca client code looks like, not necessarily to recommend that as the best way for you now to take Windows 8 to market, so to speak, or your Windows 8 clients to market. Again, Casablanca is not intended for production code. So, without further ado, let's go to the trivial server. And in this case, the server is just an executable that would run on a machine, a server, your desktop, my laptop in this case. It has a main program, like all C++ programs do. And the first thing we do is we call HTTP listener create. And this is sort of the server. The HTTP listener is the server. We give it an address to listen on. In this case, it's a local host address. And then we give it a lambda. That's what starts here at the HTTP request message. The body of the server, or the lambda that is the response to each message that comes in, HTTP message that comes in, is this message reply. We send out the status code OK with a text hello world. And then, because we're in a console application where returning from the main program would mean killing it, we have to prevent it from returning. So there's this function on the HTTP listener called listen, which will listen for messages until its body, which is another lambda, returns. And we'll just put an fgetC standard in there to wait for you to hit enter or something like that. OK, so let's run this thing. And here we see that it doesn't actually print out anything on the screen, but it's actually there. And HTTP colon if we go to the address that we had specified in the program, we see that this gives us the hello world greeting. So that is, as I said, a trivial server. Now, to look at a slightly more realistic service, we'll go to this sample called HTTP worker. And here we don't have a main program in the sense that a typical C++ console application or WinMain type of application would have. We're building a component, a DLL, that will be hosted by IIS or a other sort of host executable. And what we will call here is two functions. One is called onInitialize, which is we see on the screen here. There's another one called onShutdown. And between the call to onInitialize and the call to onShutdown, that's when our service is alive. We don't have control over the lifetime of the service. That's controlled by the environment for us. So what we do here is very similar to what we saw in the trivial example. We actually, because we're hosted, we will get data like the address. We'll get that from some configuration configuration data that is passed into us. And so what we do first is we build up a URI string from the configuration information. I'm not going to go into how that works because that's something that I encourage you to find out for yourselves in the samples. But then we call HTTP listener create again. It's the same call we saw earlier. This time, however, we pass in the URI we constructed, we built ourselves, and then we pass in 4 handlers rather than just one handler. The 4 handlers are, one for get, one for put, one for post, and one for delete. There are several overloads of the create method on HTTP listener that allows you to combine things in different ways. And there are more advanced, sophisticated APIs also that allow you to just do some of these and so on and so forth. But here we can actually service all of the 4 major HTTP methods: get, put, post, and delete. Let's run this one. And what we're going to do here, rather than have try to contact this using IE, which usually gives you a get messages, we wrote a little Win8 client. And on the screen here it says Windows 8 sample. We actually took this out of the sample, the SDK sample collection, and that's why it says that this is not a Windows 8 sample. It is a Casablanca C++ sample. And what I'm going to do here is going to do, we had this at, I believe the address here, we say star 2000. Star is as a short form of the local host name. So it's 2000 is the address. So we'll just put, we'll put localhost 2000. And it's actually at worker is the address we did. And it doesn't really matter what resource we're asking for, because they're all going to that. They're all under that top-level resource worker, so they're all going to go to that those handlers. And we have here also we can post, we can get, we can put, and we can delete. So I'll start out by submitting a post. If I switch over to this, I now see that we served a post request. I can do a put, and I see that I serviced a put response. And I can also look here at what the response I got back from the service looked like. It was an HTTP 11200, 12 bytes of content. The content type is text plain, etc., etc. And the message in the context, the content in the message is a string called that says hello world. Okay, so that's that sample. Actually, we dispatched of 2 samples here: the server, as well as that very simple client. And again, the code looks very unlike C code or things that you would perhaps expect to see unless you were familiar and really liked and were getting used to the new C++ 11 features that really make library development and design of libraries very different. Having lambdas in place is just a huge, huge advantage to library developers, and we're taking full advantage of them here. Okay, so that's the HTTP worker. The next sample is this Blackjack game service, and we'll see that it has a lot in common with the HTTP worker in the sense of, there we find it, in the sense that it also implements this uninitialize and shutdown. However, we don't actually embed the code directly in here. We have it elsewhere in a different file. In fact, we put it into a class, and the reason we put it into a class is that there's some state that we want to manage for that instance. So the Blackjack dealer, that's going to be the resource that we're managing with this server. It has some state with it. So this is a stateful service, and you can imagine that that state has some relation to the fact that it's a multiplayer game that is trying to act as the dealer at a blackjack table. All right, so we're actually doing this in something we call here a facade. The HTTP server is a facade to a service that was written using the C++ actors model. I'm not going to spend a lot of time on the C++ actors model here. It's very interesting, I think, but it takes quite a bit of talking about it to really get it. So the best thing there is to get the samples, get the download, and play with it for yourself. However, the facade uses a slightly different method of providing the implementation of the various get, put, post, and delete methods. Instead of passing them in as lambdas directly, in a create method, we have the listener created with just a URL, like you can see here, and then we manually we add the different mappings of methods, HTTP methods, to functions with a call to support. This allows us to be more specific, perhaps, right? And it allows us. It's useful, for example, when you want to defer some choices in how to map the methods to functions. Okay. We then take a look at what the various implementations do. In this case, we're not handling get yet. We put support in for it because we anticipate that we will handle it. But right now, we're just going to say not found. It's probably not the right status code here, but that's a different issue. The first thing that we do then is we handle post, and we're going to be, every message we get, we're going to print out the whole message so we can inspect it and look at it. It's kind of interesting more than anything else. We take the query that we're getting. So in the blackjack game, it's not just a simple hello world type of response, right? We actually care about the query string that comes in. That's the full resource that's relative to the dealer. And we're going to decode it. We're going to tokenize it. We're going to parse it and pull it apart into these variant pieces. And we're going to make decisions based on that. And that's what the rest of the code is trying to understand and parse the meaning of that resource that was used. I'm not going to go through all the details of that because that's what the samples are for. That's what you should be, what you can be doing yourself. And the download samples come with a walkthrough of all these code bases that is pretty in depth. So I recommend that as the best way of looking at this. But anyway, we go through and we get to the point where we send something to the proxy. And this is where we're interacting with the C++ actors model. And we're actually sending a smart pointer to an HTTP request here. So we're sort of passing that on. There is no response in here for the OK case. We see a lot of forbidden. We see not found, etc. Right? But we do not see an OK in here. And it's because we're actually letting somebody else handle the OK. Right? We're passing those on. We're taking the message, writing it down, and then somebody else will reply later. OK. Handle put, a similar situation. It parses the query, the resource. It looks for errors in formulation of the resource. And then it passes it on to the actors. We have various kinds of things here. We can bet. This is a blackjack game, so you bet on your hand, right? You can buy insurance. You can ask for more cards. You can double down, stay, etc. And delete is is used here when you leave the table. So here we're actually removing a player from the table. Okay, so I'm going to run this, and I'm going to see there that it starts up at port 80, which is the default HTTP port. And it also started some agents. It has a second address here, TCP colon. That's kind of a misnomer a little bit, I guess. It really is the TCP port that our agent's runtime is listening at. So we'll ignore that for right now. But the blackjack dealer address is interesting. And we're going to take a look at a client for this. And we're going to take a look at what the bet button, when we click deal, it actually says deal on the card, but it's when we place our bet, we're going to be hitting this handler, and we're going to be formulating an HTTP request. We have a base address that's stored in what's called here the client, the HTTP client, and then we're formulating a relative resource, and that's kind of the query. That's the data for our REST call to the service. In this case, we're doing a put. So we have formulated, first here we formulated the address, like the relative resource of the request. And then we choose the method put, and we put in the relative address that we used, that we formulated as an argument to the request method. And then we're doing something that is kind of black magic here. It is, we get and this is using PPL, we get a task continuation context use current. That is a hint to the underlying PPL which is the parallel pattern library implementation that we have available in Visual C ++11, but also we have backported to Casablanca for use in Visual in 2010. It is a hint for it to come back on the GUI thread when the response from the message comes back, from the request comes back. Okay, so we capture the context, and we then make a request. It says request.then. We created the request here, and then we've actually made the request already. That's up here. But then allows us to hook on a lambda to handle the response. So whenever the response comes, this code gets called, and it gets called on the GUI thread. Okay, so the code is this code here. And what we do is, well, we do some manipulation of text on the screen. We get the data out of the request task. We interpret the response that does some more manipulation. It shows cards on the screen, etc. Right? And then we're done. And we go back waiting for more user input. Let's run this. Okay. So the first thing I see here is I see what looks like a very straight and square blackjack table. And what I will do is I will choose a server to connect to. And here it's going to be my local host one. I'm going to shorten my name so we can see it fully on the screen. And then I'm going to click down here and say Join Table. It says place your bet, and I will be betting 100, whatever 100 let's say that's $100, right? I start out with $1,000, and I'm going to ask the dealer to deal some cards. Okay, the dealer has an ace, so I have the option of buying insurance. I'm not going to do that. 16, oh, I'll take a chance and I'll hit. Oh yeah, okay. So I'll stand on that one. The dealer wins. Okay. I'm going to deal again, and I'm going to ask him to hit, and then the dealer wins. Okay, I think this is not going well for me. So I'm going to exit the game. But what we saw there, if we go back and look at the output from the server, we will see a progression of messages coming from the client to the server. We're doing a post, that's when we're joining the table. We're doing a put for a bet. We can see that here. The amount is 100. We then do a hit. I ask for another card. I then stay, etc., etc., right? And then I bet again, I hit, these refreshes are just a protocol between the server and the client that doesn't actually involve any UI gestures. And then finally, I'll do a delete here, and I'll leave the table. Okay. And that's it. That's the service interacting with the client and playing some blackjack for me. Now, I was the only player at that table, so we didn't see the full experience there. But we can play several people on that thing. All right. So let me just go back and finish up my thoughts on this here. We want your feedback. Casablanca, the whole purpose of putting out a library like Casablanca on DevLabs is to collect your feedback. It is not intended for anything but to engage with you, the Visual C++ users, and learn from you whether this is relevant, whether this looks good, whether it looks bad. If it looks good, what features do you need? What are priorities? What things really don't matter at all? I showed you that diagram of things we could build. What don't you care about there? What do you care? What did we miss? What didn't we put on there? That type of feedback, try it out. It takes a minute or so to download. It installs very quickly, and you're off and running. You will need Visual Studio 2010 for anything that is related to Azure. So if you want to see your code running in Azure at the end of the day, you will need Visual Studio 2010. If you want to run code on Windows 8, you obviously need Visual Studio 11 and Windows 8 Consumer Preview installation. But otherwise, the requirements are pretty benign. And we look forward to hearing from you. Thank you so much.